Okay, so in the world of AI, for the longest time, the race has been all about one thing, getting bigger, more parameters, more power. But what if the next great leap isn't about size at all? What if it's about being smarter, not just bigger? Well, today we're diving into a brand new model that's doing just that, totally flipping the script. It's called Qwen3 Next, and its whole game is about radical efficiency.
So here's how we're going to break it down. First, we'll talk about this big problem in AI, the scaling dilemma. Then we'll see how Qwen3 Next offers a solution and get into its architectural secret sauce. After that, we'll check out the performance data, put it to the test. And finally, we'll talk about what this all means for the future of AI. Let's get into it.
All right, first up, the big picture. Right now, there's this huge trend in AI development, and it's all about scaling. I mean, making everything bigger, more parameters, bigger context windows, all in this relentless pursuit of making AI smarter. But this brings up a huge question, right? Is bigger really always better? Because as these models get astronomically large, so do the costs. And we're not just talking a little bit more expensive. We're talking about absolutely skyrocketing costs for training these things, and then for inference, the cost just to run them every single day. This is a massive barrier to entry. It puts all the power in the hands of a few big players and just slams the brakes on innovation. So the real problem is this. If getting smarter always means getting more expensive, how does this whole field move forward?
And that is where the hero of our story comes in, Qwen3 Next. Now look, this isn't just another model dropping. This is a whole new generation, designed from the ground up to take on that exact scaling problem. The entire goal is to finally break that connection between getting more powerful and getting ridiculously expensive.
Okay, so get this. This is the core idea. On paper, Qwen3 Next is an 80 billion parameter model. That's a heavyweight for sure. But, and this is the magic part, when it's actually running during inference, it only activates a tiny, tiny fraction of that, just 3 billion parameters. It's like having this enormous library at your disposal, but for any question you ask, you instantly know which single book to pull off a shelf. That's what's happening here. You get all the knowledge of a giant model, but with the speed and the cost of a lightweight one.
So the obvious question is, how in the world does it do that? Well, that's where we get to the really cool stuff, the architectural innovations. This isn't some simple trick with the training data. This is about fundamentally changing how these models are built from the inside out. So yeah, let's pop the hood and see what's going on.
Okay, so the team behind this packed in 4 key upgrades. We've got something called hybrid attention, then High-Sparsity Mixture-of-Experts, or MOE. There's also some stability optimizations to make sure it all works, and multi-token prediction to boost the speed. Now, we're going to focus on the 2 biggest game changers here.
First up is hybrid attention. So here's the deal. There's this classic trade-off in AI. You've got standard attention, which is amazing at remembering tiny details in super long documents, but man, is it slow and expensive. Then you have linear attention, which is the total opposite. It's lightning fast and cheap, but it's a bit forgetful. The genius of Qwen3 Next is that it just says, why choose? It cleverly mixes them together. It uses the fast, efficient one for most of the work, and then strategically brings in the powerful, slow one where it counts. You literally get the best of both worlds.
Okay, the second big piece of the puzzle is this thing called Mixture-of-Experts, or MO. And honestly, the best way to picture this is to imagine you have a giant committee of hyper-specialized experts. Now, when a problem comes up, instead of bothering the entire committee, you have a really smart router that just looks at the problem and says, for this, I only need you, you, and you. It picks out the perfect little group of experts for that specific task. The rest, they just chill, saving a ridiculous amount of computational energy.
And this is where it gets kind of wild. Qwen3 Next takes that MOE concept to an extreme. It has a pool of 512 different experts ready to go. But for any single piece of information it processes, it only calls on 10 of them. 10 out of 512. That's less than 2% being used at any given time. This is what they call high sparsity. And this is the secret to how an 80 billion parameter model only needs to activate 3 billion. It's just radical efficiency.
So the team took this super efficient base model and then created 2 specialized versions from it, kind of like 2 different flavors, each one optimized for different jobs. Let's check them out.
So on one hand, you've got Qwen3 Next Instruct. Think of this as your all-arounder, your daily driver. It's fantastic at following instructions, and it especially shines when you throw huge documents at it. But the really amazing part? It performs just as well as the company's own flagship model that has more than double the parameters. It's punching way above its weight class. Then, on the other hand, you have Qwen3 Next Thinking. And this one,
This one is a specialist. It's built for those really tough, complex reasoning problems, the kind of stuff that makes most other AIs just stumble. And trust me, it's not just good at it. It's absolutely world-class.
Okay. Those are some pretty bold claims, right? More power, less cost? It sounds almost too good to be true. So where's the proof? Let's get to the data and see how this thing actually stacks up when we put it to the test.
Let's start with the cost to even build this thing. And this number, it's just staggering. To get the same level of performance as a standard 32 billion parameter model, Qwen3 Next needed less than 10% of the computing power, the GPU hours. That's a 90% discount on training costs. I mean, that doesn't just tweak the economics of AI development, it completely rewrites the rules.
And it doesn't stop there. The savings aren't just in the lab. When you actually go to use the model, during inference, the story is just as incredible. For tasks involving long documents, Qwen3 Next is over 10 times faster. So not only is it way cheaper to create, it's also way faster and more practical for everyday use.
So let's look at the numbers for the Instruct model. Here, we're putting our efficient little model up against the company's own massive 235 billion parameter behemoth. And just look at this. On a tough coding benchmark, it actually scores higher. And on another test where humans rate the answers, it comes out on top again. This is incredible. It's not just keeping up with the giant, it's actually beating it in some key areas. All right, now for the thinking model. And if you thought that last part was impressive, this is even better. Here, it's going toe-to-toe with the big guns, proprietary, closed-source models like Google's Gemini. And on these super difficult math and reasoning benchmarks, look what happens. Qwen3 Next Thinking just wins, cleanly. Let that sink in. This is an open-source model built for efficiency that is outperforming one of the biggest tech companies in the world at their own game.
So the data is pretty clear, right? The performance is definitely there, and the efficiency is just revolutionary. But let's step back for a second. Let's zoom out. What does a breakthrough like this really mean? Why should we care so much about this extreme efficiency?
Well, the impact is actually huge. For starters, when you slash the cost this much, you democratize access. You open the doors for so many more researchers, startups, and developers to play with top-tier AI. Then there's the speed. Being able to handle massive documents so quickly unlocks all sorts of new applications that were just too slow or expensive before. Imagine analyzing an entire legal case file or a giant codebase in just a few seconds. Plus, it massively reduces the cost of AI both financially and for the environment. And when things get cheaper and faster, everything speeds up. It's like pouring fuel on the fire of AI research and development.
And really, this quote from the Qwen team just says it all perfectly. They say this is a major leap forward, and that their goal is to empower the open source community to evolve with these new kinds of architectures. See, it's not just about them winning. It's about lifting the entire community up, sharing the blueprint so everyone can build better, more efficient AI. That's a pretty powerful mission if you ask me.
So, all of this leaves us with a really fascinating question to think about. For so long, the story of AI has just been a race for more. More data, more parameters, bigger everything. But maybe, just maybe, we're watching a new chapter begin. A chapter where the real competition isn't about brute force and raw size, but about clever design, architectural elegance, and just pure efficiency. So is this the next great frontier for AI? After looking at Qwen3 Next, you gotta wonder, what do you think?